in den französischen Alpen im 21. Jahrhundert. Pierre, please.
Yeah, thank you. So my name is Pierre. I'm indeed a research engineer in the Snow Research Center in Grenoble, so dependent on Météo France and CNRS, but also from the lab ISSW, so the LESM department. Several of my colleagues are in the room also today. I will be really pleased to introduce to you the work we are doing for the past 5 years, including my PhD, so related to snow conditions impact on the economic activity of ski resorts. And after a bit of a method based on the French ski resorts, I will show you some of the results based on climate projections for the French Alps ski resorts only. So basically this method is based on spatial representation of ski resorts, based on ski lift infrastructures. So we can derive this at the scale of a single ski resort and then do this for the wide range of ski resorts in France. Particularly here you have the 130 ski resorts in the French Alps. I will introduce to you in the latest part of this presentation. So this allows to derive some really specific data on the slope angle, aspect, elevation within the resort and take really specificities of ski resorts. This can then be crossed with snowpack simulations based on the Crocus Resort version of the snowpack model, which is developed by the Snow Research Center. And this allows to take into account the snow grooming and snowmaking impact on the physical evolution of the snowpack during the season. And this is really state-of-the-art of what can be done and what should be done according to the IPCC to assess the reliability of ski resorts in terms of snow conditions for future. So we are running snowmaking really consistently with snow management strategies from interviews that we had with professionals in 2014-2015. And so we really hope now that these strategies we're using in the model are really consistent with daily professional approaches. And finally, we're using climate forcing data for the latest part of the presentation, which is derived from the work by Deborah Verfailly and the Adamant project, based on the Adamant method that was developed to adjust and downscale climate forcing data over the French mountain ranges. So this is based on 13 couples of global and regional climate models, and this is what I will use to force this modeling chain. So some of the results can be snow indicators, such as the snow reliability index. So this is a fractional index, which basically is the proportion of a ski resort with sufficient snow for skiing during the specific period of Christmas and winter school holidays every year. So you get a fractional index for a single resort and a single year, which is between 0 and 100% of the resort, where you can ski during Christmas and winter holidays. This can then be aggregated over the French ski resorts, which is the case here on this figure. And this does not include any snowmaking yet, and this is only based on the grooming only impact on the snow conditions, so this is really related to the natural snow variability, which is very important, as you can see it. Since 1960 there is a very strong variability in time. When you include snowmaking, for example here, the 45% snowmaking coverage of ski resorts, then you have a very significant improvement of the snow reliability in ski resorts, although you still have variability, which is related to the natural variability. So, for example, here you have 2001 and 2006 snow season, which are really snow-scarce season and really significantly improved by the snowmaking. The interesting point also of this fractional index is that it's really correlated to the evolution and the variability of the ski lift ticket sales. So you have here over the 2001-2015 the evolution of ski lift ticket sales in France, and as you can see it, when you take into account snowmaking, then you really have a very good match between fractional index based on snow conditions and the evolution of ski lift ticket sales. This makes this index a very good proxy for the assessment of the impact of snow conditions on the evolution of ski lift ticket sales. So based on this, and to compare with future climate conditions, I will use 15-year moving averages from now, and also to show you the spatial variability that can exist at the moment in France between mountain ranges. So you have here basically the 15-year moving average between natural snow conditions in black and with 45% snowmaking coverage, so the same as before, but with a moving average. If you look at the natural snow conditions in the Northern Alps, for example, you have a significant difference with the French average conditions, significantly better in the Northern Alps. This is the situation in Southern Alps, Jura, Massif Central, Pyrenees, and the Vosges. So, as shown before in the previous slides, then regarding the snow conditions since 1960s in France, there is a very high variability in time, but also in space. And interestingly, it's really correlated to the evolution of ski lift ticket sales over the whole French ski resorts, which makes it a very good proxy for the upcoming future snow conditions. And there is already a significant evolution of these snow conditions. As you could see it's really depending on time, but also on the location of ski resorts. So now, regarding the impact of climate change, I will limit this to the situation of the French Alps ski resorts. And you have here the situation from 1950 to 2005 for the historical period of climate models. And you have in the bold, dark line above the snow reliability index for the observational reference dataset Safran. And in gray, you have the average and standard deviation for the climate models. So the top figure is the fractional snow reliability index, and the bottom is the frequency of the scarcest snow seasons. So if we look now at the impact of the climate change on the natural snow conditions, including grooming but no snowmaking, this is what could happen based on the RCP 2.6, 4.5 and 8.5. As you notice, there is a very significant impact of climate change on the snow reliability of ski resorts. And particularly if you look at the frequency, by the near future there is very little deviation between climate scenarios. You have very similar impact, with the frequency of the scarcest snow season going from 1 out of 5 to 1 out of 3 for the reference period, to 1 out of 3 to 2 out of 3 for the near future. So this is 2030 to 2050, so this is in 20 to 30 years from now. If you look now at the impact of snowmaking, so accounting for the evolution of snowmaking facilities from 1985, the start of the spreading of snowmaking facilities in the French Alps, to 30% snowmaking coverage in 2015, up to 45% snowmaking coverage in 2025, then this is what you get, with a very significant impact of snowmaking on the snow reliability of ski resorts in the French Alps. So you have here a very stable situation in the near future compared to the reference period, both in terms of reliability, but also in terms of frequency of the scarcest snow seasons. So this also depends really little on the scenario you consider for the near future, but beyond the mid-century, then you have very significant dispersion between scenarios, and snowmaking might not be able to compensate for the decrease of natural snow conditions. This can also be due to the decrease of the suitable conditions for snowmaking as well. So this is a combined effect. So of course, this can only be achieved with significant impact on the snowmaking requirements and a very significant increase since 1985. So you have here the evolution of snowmaking facilities, the dotted line. Here you have observations of water volume requirements, and you have here the evolution computed by our method, and which shows that from 1985 to 2025, then the evolution of snowmaking requirements are mainly driven by the evolution of the surface area equipped with snowmaking facilities. And then, beyond 2025, then the decrease of natural snow conditions involves a really significant increase also of the requirements per unit surface area. Basically, compared to the reference period, there is a 10 to 20% increase of surface water requirement for snowmaking. So this is part of the results we have, but this is also, this can be done at the scale of a single ski resort, as I said, or a category of ski resort or a regional part of the French Alps. We expect also to do this kind of work outside the French Alps. And if you have any questions or query, feedbacks on this work, I will really be pleased to discuss it with you, and thank you for your attention. Thank you.
Thank you, Pierre. Would you say it is correct when I summarize your presentation that we can still advise our children to run a ski resort, but not our grandchildren?
How old are they?
Well, it depends how quick you are.
Now, of course, I will go for a research answer. It depends. This is a situation aggregated at the scale of the French Alps, and this is very important. The situation is already very different, depending on where you are and what kind of resort you are, what is your range of elevation. So, of course, this is a general situation, and the situation is already critical in some of the resorts that we are working on.
Okay, thank you. Irgendwelche anderen Fragen noch? Gibt es noch jemanden?
I presume this isn't an issue in the Alps, but is there anywhere that the availability of water might be in question in the early season when glaciers become less and
Yeah, of course, this is only requirements, but this is not availability of the resource. If this is related to your question, right?
Right. If you don't have water, you can't make snow.
Yeah. Yeah, so this is a central question, but this is beyond the scope of what we're doing. And we are computing requirements, so this can, for example, be used by operators in resorts. Like, if I expect to have like a factor 2 to 3 increase in my water requirements, then can I do it? Or is it possible in terms of environment and resource availability, and depending also on the timing? But this can be done. We are doing like daily computations of it. So this can be accessed, and then this already has been used by some of the resorts in the ISSW, which is a regional part of the French Alps. And so yeah, this could be used, but this is beyond the scope. Yeah.
Okay, thank you very much.